So as we took a look at yesterday, we discovered the difference between independent and dependent events. So now we're going to take a look at some probability examples. Remember, independent events kind of stand alone. What happens on the first event does not impact what could happen on the second event. So a lot of events like flipping a coin, rolling a die, spinning a spinner, what you flip the first time on that coin does not change what could happen the next time you flip the coin. Then we have dependent events, and that's where you take something out and you don't put it back. So when you're dealing cards from a deck of cards, or you're eating candy out of a bag and you don't put it back, those are dependent events. Once you take that card away or you take that candy away, it changes what's left. So it changes the probability of what could happen next. Our first set of examples, we're just going to see if we can decide whether or not the events would be independent or dependent, and we're not calculating any probability yet. Starting off with our first example, spinning a spinner. What happens on the first spin does not change what could happen next, so these are independent events. Eating M&Ms. Well, once you consume it, it doesn't go back in the bag, so these would be dependent events. Dealing cards from a deck. Once you deal a card to a person, it is no longer in the deck to be dealt to the next person, so that would be dependent. And finally, catch and release fishing. If you catch the fish and then put it back, it's still in the lake for the next person to catch, so those would be independent events. So before we start our probability, the first thing we're going to decide is, are these events independent or dependent? And that will help us get the probability organized. So if you roll a die and then you flip a coin, does what you get on the die change what you could get on the coin? No, so these would be independent events. So we're just going to multiply the probabilities together. The probability that I roll a 3 on a die is 1 out of 6. There's 1, 3, and 6 numbers on the die. And flipping heads would be 1 out of 2. There's 1 chance to get a heads, and there's 2 possibilities when you flip a coin. Multiply your fractions straight across, and we get 1/12. This next question is for my boys. Jeremiah and Eli love to collect coins. So if my husband has 6 nickels and 4 dimes in his pocket and he randomly grabs 2 to pay Eli to pick up after him, what's the probability that Eli ends up with 2 nickels? So after Josh pulls a coin out of his pocket, does it change what he could pull next? Yes, once the coin is pulled out of his pocket to pay Eli, it's no longer there for him to choose again. So the probability that the first coin he pulls out as a nickel is 6 out of 10. There's 6 nickels and 10 total coins. Once he's pulled out a nickel, there's 5 nickels left, and now there's only 9 coins. He's given Eli 1 of them. I like to simplify before I multiply, so I'm going to cancel my 5 into the 10. 5 goes into 10 twice. 3 goes into both 6 and 9, so I'm going to divide each of them by 3. And then I see I have 2 over 2, which simplifies to 1. So that leaves me with a probability of 1/3. There's a 1/3 chance Eli will end up with 2 nickels. Here are your 2 you try questions. Decide if they're independent or dependent first, and then set up the probabilities.